Now let us examples related to subnet masking. So first condition that we are going to consider is hosts on the same logic, if same logical network will have identical network addresses and can communicate freely. For example, the following two hosts are on the same network. Host A is 158.80. These are the first two octets, and then 164.100. Okay, and then subnet mask that we have used is 255.255.0.0. This means the first two octets are identifies network, and second two octets identify obviously host. So and host B consists of 158.80 again with the same subnet mask, similar subnet mask. That means the first two are network and second two are host. So they are in the same network. By looking at the IP addresses, we can say that both are in the same network, but the host identification is different. One host A identification of last octet is 100, and host B last octet is 101. So both share the same network address, that is 158.80, which is determined by the 255.255.0.0 subnet mask. Because of that only we are able to make out which part identifies the network and which part identifies the host. So hosts that are on the different networks cannot communicate without an intermediating device. So now let's take another example where where we can have a different networks. Both are in different networks. So for that we have to look into the uh, subnet mask only. So subnet mask is very important, very important. So now the second example that we have considered is the subnet mask. If you see, the subnet mask has remained the same here, but the network, if you see the following example, the subnet mask is 255.248.0.0, and then other subnet mask is 255.248.0.0. So first one is 255. That means the first octet uh, will definitely represent what do you say, sorry, network. And then the second octet, how many bits in second octet will represent a network, and how many bits in second octet will represent host, that we do not know. For that reason we need to look into the subnet mask. Sorry, in that for that reason we need to look into the we need to convert it into the binary form. So let's convert this into the binary form. So here is host A consists of this, that is IP address, and host B IP address, and the subnet mask is this. Okay, so as both has the same subnet mask. If you see first octet, the first 8 bits represent obviously network, but whereas in the second octet only 5 bits will represent network, and then last 3 bits of the second octet will represent your host. So now we have only 2 octets, that's it. So anyway, the last 2 octets obviously represent host. So now based on that, it's very pretty clear that host A and then host B. So you have to consider these first two, and out of which the first octet is same but the second octet is not same. Of course, their host ID is same, but the network is not same. You see, 158.80 here, 158.79. So these are in different networks, but in their network, but they have a same host names, same host IDs. That's what here basically the two hosts are not on the same network and cannot communicate without a router between them. If they are in the same network, you do not require a router to communicate with each other. They can communicate with each other without any router. So that's how it works in the if you create instances that we will do in Kubernetes. If you create instances in same region, same subnet, same VPC, you don't need to have a router to communicate with each other. So there we create a Kubernetes cluster. I will show that. So don't skip the course after completing the networking. You just follow the whole course, because there is a lot of stuff ahead, lot of knowledge ahead, and lot of practical workings and lot of practical exercises ahead. Okay. So now, normally the hosts which are not on the same network cannot communicate without a router between them. So that's why routing is the process. Routing is must and should for communicating two hosts which are in different networks. So routing, what is routing then? Routing is the process of forwarding packet from one network to other network. That's what is called a router. At your home you might have a router. So what does a router do? A router basically forwards a packet from wide area network to your local area network. That's it, nothing much. That's what is your router. So here you can see we got yeah, host A's network ID and host B's network ID. You can see they are not at all same. That's a clear-cut explanation I have added here with the binary digits. Always, if you want to understand exactly the IP, you have to look into the binary. If you look into the binary, then only you will get exactly what's happening behind, or else it's difficult to figure it out. So 158 and 157, 158.80 and 150.7, and this is our network. If you look into the binary, so it's completely different. Okay, the first two octets are same, but the second octet, the five bits are not similar. So there is a difference. So that is the reason these are two different networks, and the host A is in different network, host B is in different network.